Hi. Now we are going to go from log form. So all these have the word log in them.
That's quizzes.
Is it? Oh no. Okay, sorry. Apparently I had a tab open for one of my kids' quizzes. Um, I got that taken care of though. So now we're going from log form to exponential form. So in my directions, this is what I have. This is what I'm trying to do. I need to write it so that it has an exponent. So in order to do that, I still will start at the same base number. So my base is 2. I'm going to raise it to the equals number is my exponent to the third. And then it equals the number 8. And like on something like this one, you can see that that's true. Is 2 cubed 8? Yes, it is. Okay, so then number 8, we start with our 2. That's our first number. Raise it to the negative first. And that equals 1/2. Is 2 to the negative first 1/2? Yes, because we know a negative power will move it to the denominator and raise it to the first power. All right, number 9, we have 3 raised to the fifth equals 243. 10, we have 5 raised to the negative second equals 1/25. That makes sense. That would be like a 5 squared in the denominator. 27 to the 1/3 power equals 3. That is true. We know a 1/3 power is the same thing as saying the cubed root. And we know the cube root of 27 is 3. And then for 12, we have 52 raised to the 0 power, and that equals 1. We know when we raise a number to a 0 power, you get a 1. So those are now all in exponential form. Do they all have an exponent? Yes. And we can check them with our arrows to make sure that they're all in the right order. So basically what happens is you leave the first number the same and then the last two switch places. Leave first number as first and swap the second and third. Okay. Evaluating a log expression. So on these problems, we can rewrite them into exponential form, and I also have like a shortcut that I do to solve these. If you put them kind of like in an exponential form, sorry about that. So now we have log, hold on, not that pen. We have log base 49 of 49 equals something. You could call that x, like a variable. So if I were to write that in exponential form, I would say 49 raised to what power equals 49? Do you know the answer to that? That's a 1. 49 to the first is 49. So we're looking for basically the exponent in all of these. And I was telling you I have like a shortcut if you can change them into the same base. What you can do is, I'm just going to shrink this down here so I have space. What you can do for these, let's draw a line here. Okay, what we can do for these, if you have the same base or the ability to write them as the same base, 49 is just 49 to the first. 49 is just 49 to the first. And then if you're looking for your answer, all you have to do on these is just go 1 divided by 1. And that gives you your 1. So that's kind of weird on this particular problem, but when I show you on number 14, it looks a little bit better that one because the numbers are different. But we'll look at like 2 and 32. 2 and 32, can we write those as the same base? And you can't, because we have log base 2, so 2 is 2 to the first, and 32 can also be written as a power of 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So we can see that 32 is 2 to the 5th power. So now that we did that, now you can just take 5 and divide it by 1. 5 divided by 1 is 5. Does that make sense? Otherwise, you can go log base 2 of 32 and then say equals x and just do 2 to what power is 32. It's really the same thing. This is just kind of like a neat, more organized way of rewriting them. I'm a fan of it. All right, 15, we have, all right, 15. Can 3 and 8 be written as the same base? Yes. We have 3 to the first, and then 81 is 9 times 9, so it's 3 times 3 times 3 times 3, or 3 to the 4th power. So if you were to do the shortcut, that would just be 4 divided by 1, which is 4.